Welcome to this short course on the fundamentals of process measurement, in particular the use of multimeters. The first look at that we'll have a look at is what a digital multimeter is, and it's the most common practice one that you do have around the world. And it comes down to understanding what is the instrument going to give you, and also have a look at how the instrument is laid out, including the LED display, the front panels, the ability of being able to connect it properly, and more importantly, as it becomes part of your safety equipment, and in most jurisdictions is referred to as personal protective equipment, it's understood that you need to have a look at the safety of the unit, including the conditions of the lead, the making sure that the amps or the current leads or terminals and or fuses are intact, and that you do get a good continuity and issue about it, and that you do have overload protection on your current and also your ohms range, because a lot of it may create as I said, a safety issue, which if incorrectly set up may create a problem for your user. Okay, so most multimeters are exactly that. They do have 3 or 4 different functions within them. Most multimeters do have a voltmeter or a potentiometer, a potential meter put in them. A lot of them do also have a ammeter or a current meter, of which some may be restricted to DC, but some may be ranging from AC to DC. It's important to make sure that the system is suitable for your actual application. So if your local regulations do call upon safety issues, and also as good practice as well, make sure that the system is safe for your actual application. Make sure that that when you're looking at the system, how it is actually ranged. A lot of different styles of meters do have a fixed range, and you can select those by the rotary dial generally, or some of them may also have auto ranging. In other words, they look at the reading at which you currently have, the range of the system that you have, and then put that into a range the dynamic characteristics to best suit the inputs. Okay. So the majority of the instruments are double insulated. So, and that means that if you do have a meter that is handheld, then you need to make sure that the integrity of the componentry and also the casing is intact. So look for things like safety ratings, fuse ratings, any type of certification that is, and making sure that you never operate the system without the back cover, because it exposes the user to the full voltage of the applied voltage. So make sure, because the back cover is an integral part of the casing, make sure it is in place and intact when you actually operate the system, because as I mentioned before, it is highly likely that the full voltage which you're sensing is to the exposed metal parts in the cover, under the cover. So what do the common practices are in the symbols, and these do vary from manufacturer to manufacturer, but the most common symbols are voltage DC, as you can see, voltage AC syndicated by a simulation of a sine wave. Then the millivolt reading, the ammeter in both milliamps as well as in microamps, the ohms symbol signifying resistance, and one which is very specific to types of instruments and ones that may not always be available in all instruments, is that a continuity checker. So it's basically within resistance mode, but if you do have a short circuit, it will actually create a noise, generally a buzzer or a beep, when you do have no or minimal minimal resistance, and it is there mainly to be used for something like checking the continuity of a cable. So when we look through and make sure that the instrument is suited for purpose, making sure that you check the leads, make sure that the resistance of the leads are definitely within range. Most meters will, when they're short-circuited, show a resistance reading of roughly between 0.1 and 0.5 of an ohm, and that is mainly to make sure that the lead resistance doesn't affect your reading. And if it is higher than that, then you may need to investigate the integrity of the lead. Make sure that you do have no damage to the lead. Make sure that there is good, and that's both in the connectors, the terminal pins, as well as all the way through the insulation of the lead, and also at the tips. So make sure that they are not broken, and a good way is to actually run your hand the full length of the lead and look for any abrasions, anomalies, or joints within the leads, because it will indicate at least a failure point in the future. So one of the classical things of very closely trained and also common incorrect wiring of the multimeter is that because of the sensing characteristics of voltage does rely, or measuring the voltage of a circuit relies on the instrument, the multimeter, for instance, to be very high impedance, whereas the measuring of a current within a system requires a very low impedance. So because you don't want to put any extra load or a resistance in series with the actual current, so you need to make that as the impedance within the meter as low as possible. So one of the classical errors that can occur is that you continue to you've done a current check or an ammeter. You then try to measure voltage without changing the thing, and it is one of the things that many apprentices and many technicians have to be aware of, but a lot of meters will have some type of protection for overload, and hence make sure that the fuses are intact. And this is one of the classical ways where a meter may fail as well. So be very important, very careful on how you actually use your meter. Then, as mentioned before, the way to measure voltage relies upon very little loading down the circuit. So hence it has to be a high impedance. So make sure that that you do have at least some current flowing through it, even though it is high impedance. In other words, make sure that the leads and any type of thing don't indicate that you don't have a voltage across it, and that's very important, because if you're using it to check voltage, make sure that the leads prior to you checking it are intact, and then check the voltage again, and then possibly, and good practice is to recheck the meter again to make sure that it is still functional. So it is possible that during the check that it may fail due to a high voltage or out of spec voltage. So it's important to go through the three-step test to a known, test the unknown, and then test the known again. So common problems which could occur in a multimeter are that you apply too high a voltage to it, that you are either putting voltage or current. You're measuring voltage when either the resistance or the continuity circuit, in other words, a overload. You're measuring current jacks as well, so it's important to make sure that the fuses are in place to restrict, at least in the long term, the fuse will blow because it is a low impedance and you put a voltage across it, therefore a high inrush current will occur and therefore the fuse will blow. And also making sure that you have no exposed metal parts. In other words, you fully use the case as directed by the manufacturer, and that you also make sure that the system itself is closed and you don't have any type of exposed metal parts. Thank you.